Hello everyone and welcome to Kinemarc. So today, under the supervision of Dr. Sani Mubarak, in this tutorial we are going to learn how to design, analyze, simulate and also optimize a microstrip patch antenna using HFSS. Now before you decide to design any antenna, you should one, know the purpose of the antenna or the application type. That is, you must decide what your antenna will be used for. For example, antenna for millimeter wave application, as you can see, will be from 24 GHz to 28 GHz band. If it is a WLAN or Bluetooth, as you can see, you can have 2.4 GHz and also 5.2 GHz. In other words, you must establish the operating frequency or the resonance frequency of the antenna you will want to design. Two, you should determine also the antenna type. You should know whether you are designing a patch antenna, a monopole antenna, or a dipole antenna. So these are some pictures of how the patch antenna, the monopole antenna, and the dipole antenna looks like. Again, you should know the substrate type for the antenna. So the substrate consists of the dielectric material needed for support, that is the mechanical support for the antenna or the radiator. So knowing that, you can choose to use RT duroid as your substrate, a foam substrate, FR4 substrate, or Roger 4350, and etc. Now the criterion for selection of the right substrate for your design could be either the price, the efficiency, or the size of the substrate. For example, to achieve a minimum size, the use of the foam substrate is the best, but it is very expensive and the losses in that foam substrate are higher. That is leading to very less efficiency. Now to also achieve a maximum efficiency, normally we use the Roger 4350. That is the best substrate to use when you want to achieve maximum efficiency, but the size of this substrate is very much bigger and it is not cost effective. That is, it is very expensive for purchase. Right, so FR4 substrate is the optimal solution for minimum size, and the price, since it is very cost effective and has much smaller size, but it is sometimes requirement dependent. All right, so you should know what you want so that you can choose the right substrate for your design. So this is very key when it comes to antenna design. So what at all are we going to design in this tutorial, or what kind of antenna are we going to design? We are going to design the edge-fed microstrip patch antenna. Microstrip patch antenna in recent years emerged a lot in different fields of communication. Such as mobile application, satellite application, wireless, local areas, etc. And this microstrip patch antenna is a very popular antenna. And this microstrip patch antenna is a very popular antenna because of its lightweight, volume, and also when it comes to fabrication, it is very easy to fabricate. That is, it can easily be placed on a PCB, that is a printed circuit board. So that makes it relatively cheaper compared to other forms of antennas. So we are going to design this basic type of antenna in HFSS. Also, to design an antenna, you should know the specifications of your antenna. So in this tutorial, we will have an operating frequency or the resonant frequency to be 2.4 GHz. As I said, you should know your frequency. We are also going to use substrate type, that is FR4. Also, the substrate is going to have a dielectric constant or the relative permittivity of 4.4, and our substrate height or the thickness will be 1.6 millimeters. Right, so when you take a look at the dimensions, here you will see that we have a ground, we have the substrate height, that is h, and we have a dielectric constant or the relative permittivity of the substrate, And on top of the substrate is where we have the patch and we have the feed line. So the patch should have a certain length. It should have also a certain width. The substrate should get a certain height, and also your feed line should also have a certain length and width. So we are going to learn how to calculate all these things. In fact, there are formulas for calculating the length of the patch, the width of the patch, and also formulas for calculating the length of the feed line and the width of the feed line. So to make everything easy, you can just visit www.emtalk.com so that you can calculate your patch antenna length, the width, and also the feed lines length and width, because there are calculators over there, very easy for you to compute and get whatever values that you want. So we'll try and see how to calculate these values without using the formulas, right? So let's see. Now, to determine the length and the width of your patch and your feed line, as I said, we will visit www.emtalk.com. Alright, when the page opens, this is what you will see. So as you can see, the name is Microstrip Patch Antenna Calculator. So this is a calculator which will help you get the length and the width of your patch. So it needs certain inputs before you can get these values. So one, it is asking for your resonant frequency. So in our design, we are going to use 2.4 gigahertz, as you saw in the presentation, and we had the dielectric constant to be 4.4. We had the dielectric height, or in other words, the substrate height, to be 1.6. Right, so after these inputs, you just click on synthesize, and now we have our length size and the width size over here, very easy to calculate. And it also gave us the input impedance of the patch, that is 243, which we should take note. Alright, so after calculating the patch, you also need to calculate the length and the width of the feed line. So to do that, you click on tutorials and tools, and you come to Microstrip line calculator. You click on this one, so you see that the feed lines length and the width will also appear over here. So in general, the feed line is designed to have an impedance of 50 ohms, and the electrical length is 90 degrees. And again, our dielectric constant was 4.4. The dielectric height, or the substrate height, is 1.6, and we want to design this antenna at a frequency of 2.4. So now after these, you just click on synthesize again to give you the length and the width of the feed line for you to be able to design your microstrip patch antenna with ease. So now, since we know the values or the dimensions of the patch and the feed line, we can start designing our antenna in HFSS. Alright, so in summary, from EMTalk, we had the patch width to be 38.04 mm, the patch length to be 29.44 mm, the feed line's length to be 17.12 mm, and the feed line's width to be 3.06 mm. So with these values, let's move straight to HFSS and start the design. So for us to design our microstrip patch antenna, we need to create a new workspace for whatever we want to design. So you click on this, insert HFSS, design, and this is the interface that will pop up. So this is where we are going to design our microstrip patch antenna. So let me save the file and give it a name. Let's say Platini continuous patch antenna. Alright, so I will save it. So after saving it, now you can start with your design. Okay, so we will start by drawing the substrate. Right, so when you take a look at the nature of the microstrip patch antenna, the substrate has a certain length, width, and a certain height as well. So the best shape to use over here is to use a box, because a box has a height, a length, and also a width. So to use the box, you come up here and you click on draw box up here, bring it here, and just a click, you can draw your substrate. So we give you a certain height like this. So now this is our substrate. So I'll come up here, click on this one, and change the name to substrate, so that I can easily identify my design and all the parts that I'm going to use. Right, so you click here, go to create box, and this will give you the dimensions of the substrate you've drawn. So you can change the size of the length, the width, and also the height. So the substrate height, if you remember, we said we are going to use 1.6, so I'll change it to 1.6. And the length and width, you can use, let's use 70. So I'll click OK. Okay, so now this is how my substrate looks like. It has a height of 1.6 and a width and length of 70 mm. Right, so this is how you draw your substrate. Very, very easy. Now, from our design specifications, we said we are going to use FR4 epoxy as our substrate material. So how do we change it? Click on substrate, and now by default the material here is vacuum. So I'll just click on edit, and I'll search for FR4 epoxy and this libraries. So this is it, with a relative permittivity of 4.4. Click on OK. Now material is changed from vacuum to FR4. So with this, we are done with the drawing or the design of our substrate. So the next thing that I will draw is the ground plane. So when you take a look at the microstrip patch antenna, here you will see that the ground plane is beneath the substrate. It is not on top of the substrate. So we should also draw it in such a way that it will be under the substrate. Alright, so let's see how we go about that. And the ground plane is very flat, or like a flat sheet. So now we are going to use rectangle, because it does not have a height or anything. So we will use a rectangle which is flat as well. So I'll click on rectangle, bring it here, and mind you that the ground plane should also have the same dimensions as your substrate. So let's see, I want to know if my ground plane is beneath the substrate, not on top. So I'll click on this and I'll move it up, and I'll see that okay, my ground plane is down or beneath the substrate, as you can see in the as you can see in a purple color, it is beneath the substrate. So similarly, I'll double click on the rectangle and I'll give this one a name, which is ground plane. It is very good for you to name all your components so that you can distinguish between which is which. All right. So the next step is for us to draw the patch on the substrate. Right. So to make the drawing very easy, I'll click on this and have the topmost view of the substrate so that I can draw the patch on it. All right, so let's see. The patch is also a flat sheet on top of the substrate with no height. So I'm going to also use a rectangle. So I'll place it on top like that. And now this is the patch. So I will just rename this one to patch for easy identification. Let me change the color of the patch into, let's say, orange. Okay. Now this is the patch. So let's click on create rectangle and give them the correct dimensions. So if you remember, the dimensions we had for the length and the width is what we have as X size and Y size over here. So now our Y size is the length. So for the length of the patch, we had 29.44 millimeters, and we had X size, that is the width of the patch, to be 38.04 millimeters. So just click that. So now this is the patch. Now we have to also draw the feed line, because when you look at the structure of the microstrip patch antenna, it has a patch and a feed line on top of the substrate. All right, so I will click on rectangle so that I can draw the feed line as well. Okay, so quickly I will rename it into feed line. All right, and I'll click OK. So feed line, let me go to create box and give the dimensions of the feed line. So now the feed line's length, that is here Y size, we had 17.12 mm, and we had the X size, that is the width, to be 3.06 mm. Okay, so I'll click OK. So what we are doing is that we want the patch and the feed line to be on top of the substrate. So let's see if it is on top of the substrate or beneath. From this we can see that the patch and the feed line are beneath, that is, it is where the ground plane is, but we want it on top of the substrate. So we go to, for the feed line, we go to create rectangle, and the positioning, we give it a height of 1.6, that is in the Z direction. So you see that it will come up. And also for the patch, this is the patch which is down, we want it up on the substrate, so click rectangle. So for its Z, or the height, we are going to give it also 1.6 so that it will be on top of the substrate. So now when I click on the patch, you see that it is on top of the substrate, not beneath. So let me position the patch very well so that, okay, so the position, let me say I have the X part to be 15, and the Y part to be 17. All right. So this is how it looks like, right? But from the structure of the microstrip, we saw that the patch and the feed line are all joined together. So how do we do that over here? We have a function called unite in HFSS. So I will click on the patch and click on the feed line and click on unite up here. So you see that right now the patch and the feed line are united. They are one. All right. We are not done. What we have to do is that you can see that the ground plane is unsigned, the patch is unsigned. That means we have to assign boundaries to them. So for the ground plane, we will assign a boundary that is perfect E. Okay. So for the patch, which is also unassigned, we will also assign boundary to it, perfect E. All right, now what we have to do is to draw or give your patch antenna a port. So let's see how we can do that. You have to change the drawing plane to ZX. All right, so for the ports, I'm going to also use rectangle. So the ports will be somewhere here. So I will name it over here, give it a name, spot, click OK. But the port is unassigned, so I'll have to assign it. So I will assign the port with an excitation. I'm going to use the lambda port. All right, so give it a new line. Once your new line is correct, you see defined here. So let's see if we've assigned all boundaries and excitations to our design. So for boundaries, when I click on perfect E, you can see that the ground plane is assigned with a boundary. Perfect E, you can see that the patch is also assigned with a boundary. Excitation, you can see that the port is also assigned. All right, so with this we can click on this one up here and see what we have to do in order to get our results. So everything here is checked, which means the design settings is okay, 3D model okay, boundaries and excitations are checked, mesh operations checked, but analysis setup, we have a problem over there, so we have to do it. How do we do that? We have to place a radiation box around this microstrip patch antenna over here before you can run your simulations. So a box, you click on this, But before that, you need to change your drawing plane to the XY plane.